Decisions, decisions. Hello YouTubers, now that we've removed the battery from the Chinese clone electric longboard, how do we go about charging them? Well, there's two ways: a standalone third-party charger, or we can use the onboard battery management system. There are advantages and disadvantages to both approaches. The first approach I'm going to cover is using the BMS as a standalone charger. The first advantage of this method is you don't have to modify the battery at all. The other advantage is it's free. This and the power supply unit you already have. It's also fairly accurate. If you've seen previous videos, you'll know that this is a weak point on the board. It tries to restrict the current to the motor and sometimes it will blow as a result. But as a charger, it's fine. I've used it on my battery several times, tested the result using my multimeter, and it's spot on. Disadvantages. Well, the first, it won't charge standard off-the-shelf batteries. So if you wanted to experiment with the batteries in your board and replace the standard one that's inside the Chinese clone casing, say for example with a high capacity battery, this won't charge that battery. The fitting here is incorrect. I'll be covering that shortly. It's not covered, but that's easy to fix. You could put this in a Tupperware box or a simple project box, and that'll stop anything from falling on that. If you're going to use the BMS as a standalone charger, this is how you do it. First thing to note, these wires here, you don't need any of those. You can just remove them, snip them there. You just need these here. This, covered with a bit of tape or something, if it's present. You can remove that and join those together. So it's just, I can show you that properly, that arrangement there that you want. From here, you want to plug the battery into this. Now plug in the power supply, but don't connect this to this just yet. Let's plug that in. The reason why we don't plug the power supply in straight away is we want to mimic the behaviour of the board. This arrangement here, the battery and the BMS, this is how it would be on the board. This is always connected. This isn't. When you do charge it up, you want to plug the power supply into the wall first and see that green light. Hopefully you can see that on the camera. When you know that's like that, this is like this, then you plug them together. That goes red, and you know it's charging. Unlike fancy off-the-shelf chargers, there's no feedback mechanism here. You don't know the state of the charge. It's just that red light that you'll have any feedback from. So keep an eye on that. Red means it's charging, and it's green, it's done. It's a bit later, and that's turned green, which means the battery is charged. So let's disconnect that. Okay, so how accurate is it? Well, the first cell is 4.2. Actually, let's just increase the accuracy a bit. The first cell is 4.20. Second cell 4.19, 4.19, 4.19, 4.19, 4.19. So it can be seen the BMS is perfectly fine for charging up the Chinese clone batteries. Okay, that's the BMS used as a charger covered. The second option is to use a off-the-shelf balance charger to charge your batteries. This has its own advantages and disadvantages. Advantages include charging off-the-shelf 6-cell lithium batteries. Any off-the-shelf 6-cell lithium battery. They come with standard fittings, and as a result you can experiment. You can take the existing battery out of the Chinese clone longboard, put in another 6-cell lithium battery, but one with a higher capacity, and charge it on this. That means you can increase the range of the board at a stroke. Other advantages include, depending on the charger, being able to put the battery into storage mode and monitoring the state of each individual cell. And you can also use battery testers such as this. Disadvantages? Well, there aren't many. And the first is the lead. It has to be modified. These aren't compatible with off-the-shelf battery chargers. Another disadvantage is using an off-the-shelf battery charger is not quite as convenient or as easy as the BMS in the board. You can't just plug it in and forget about it. There's a bit of programming involved. I say programming, I mean pushing a couple of buttons. But if you've got saved profiles on your battery charger, that's easy. And the last disadvantage is it's going to cost. Not much though. You can get a budget balance charger in the UK for £25–30. If you're going to follow this approach, this is how you do it. The first thing to do is to modify the leads on the battery. If you look closely at my previous videos, you'll see that these two are actually different. This is standard. This is as it comes out of the Chinese clone board. This one's been modified to work with off-the-shelf chargers. This is a standard fitting. This isn't. Now let me show you that closer. Can you see that? A standard 6-cell battery should have 7 leads, 7 holes in the terminal, 7 contacts. This is one on the Chinese clone, and it's got 6. You can see quite clearly there's an extra one. So what's missing from the clone battery? Well, there should be a wire going from here, negative, to here. This might help to explain it a bit better. Should be 7 leads, 7 wires here. On the Chinese clone longboard, this one is missing. It just goes from here to the main negative lead there. As a result of that, these 6 wires are all shifted up by 1. So that one goes here, where that should go. And that goes there, and that goes there, and so on. So it's all been shifted by 1 that way. Hopefully this will make things a little bit clearer. This is the clone plug. This is the standard 7-wire 6-cell plug. To turn this into this, you're looking to take all the wires from here and shoving them down one. So you go from that sort of arrangement to this, and you expose the topmost terminal. And that wire there is taken from the negative here. If after having cut the wires and you've got a whole bunch of wires and you don't know how to wire them into here, what order? Well, the multimeter will help you out. I'm trying to hold that in there. If you put that one in the first terminal and that in the second, you're registering the voltage of the first cell. That should be between 3 and 4 volts ish, like that. The second one should go up 1 increment of that, 7.6, and the third another increment of that, 11.5. That way you'll know if you've got the wires in the correct order. Do take note of the way I was holding these in the previous clips. To make this mimic this, I was holding it that way up and shoving everything down one. When I was measuring the voltage, I was holding it this way around and going from that side to there, from right to left. So there are your 2 options. You can leave the battery standard and use the BMS. You can modify the battery and use a off-the-shelf charger. I did plan to show you how to charge these batteries in parallel using the BMS or the balance charger, but had an accident. Like an idiot, I was modifying the wiring on one of the boards. I left this plugged in, and as I was cutting through some of the wires in the circuit board, or not the circuit board, but some of the wires going to the circuit board, I cut through two of the leads at the same time using a metal wire cutter and shorted this out. So one of the cells in there doesn't work. It does give me a chance to show you the battery tester. So just go through this. Okay. And cell 1, cell 2, cell 3, cell 4, nothing. That's the fourth cell. Lovely. But never mind that. That gives me an excuse to open this up and have a look inside. I don't expect to see anything exciting, but I am curious. Next video is going to be about the ESC, and you've already seen me replace it with a like-for-like replacement. The next video is going to be about an upgrade, which should change the character of the board substantially. Anyway, until next time, bye for now.